The last edition of the code is 2002. So the designs which were made, let us say, after the publishing of the 2002 code would come out in something like 2005 in the actual construction. In the last code, that is 2002, the forces for which you would design a building have been doubled almost. I mean, in a simplified manner. Now, if you have a building which was designed earlier for some forces, and now you say the forces that it should take are 2 times what you have designed for, obviously you cannot say it is safe. You cannot say it is unsafe either. You have to check as to what happens to this building. Unless you make a detailed study, you are not sure whether this building is safe or unsafe. So there is no formal study as such which have been made. But if you really look at it, if you double the forces, unless it's a very uneconomical design, probably the building is not safe. Apart from the doubling the forces, there are many other features in the building which are introduced, like the concept of ductility, which ensures the structure is resilient. Just making it thicker or something like that, we should probably enable it to take more vertical loads, like you can make another 2 stories on top and nothing would happen to the building. That is all vertical loads. As far as seismic forces are concerned, they are not vertical loads. The whole ground is shaking, and as a result, that whatever is the your mass inertia of the building, that starts shaking the building in the horizontal direction like this. So it's a horizontal force which is introduced. It's got nothing to do with the vertical capacity of the building. So these concepts have come out only recently. How to make a building ductile, how ductile it should be. These were never answered in the earlier codes. So the question is still out as to how many buildings are safe or unsafe. But most experts, let's say 50% of the buildings are still safe, which were designed earlier. We are comparing it with what we consider safe today, not what we considered safe 10 years ago, 50 years ago, 100 years ago. The concept was completely different. So we are talking about in the present context, which is in the National Building Code of India, which is published by the Bureau of Indian Standards. As per that code, if that is going to be the benchmark, are we going to say that things are safe or unsafe? If you go by that, I would say that at least 80% of the building in the city you cannot say that they are safe unless you make a detailed study of that. We have been making, you go to Chandni Chowk, you go to many of these places, the buildings have come up cheek by jowl. That's the most dangerous thing to do, because not only are you endangering your own building, when you have this severe ground shaking and some part of the building collapses or has some defect or even deflects too much, you are endangering even the neighbor. Here you got many buildings have a common wall. So what are we trying to do? How can you say whether it's safe or unsafe? If your building is safe and the neighbor is unsafe, your building is also unsafe. So there are many issues like that which come into the picture, and then there are so many unauthorized constructions. There are so many places where people over the years have made modifications and changes in the structure. People have taken out balconies, they have made a big large opening in the wall. Now all this, you cannot say how unsafe you are, but whether you are safe or not is a question mark. So I think 80% of the buildings in Delhi come in that category. You see, what people have come up with this fancy word called potential of liquefaction, which basically means that the ground has got no bearing capacity. If you put your foot on it, the whole foot is supposed to go inside. Now that type of situation can occur. When does it happen? It happens firstly only when the ground is saturated and the substrata consists of poorly graded sand. Poorly graded means that you have a big gap. It's not something which is uniform like that. You have the smallest and the largest particle, and it is all uniformly distributed in between. It is something here, and then there is a lot of things at the lower level. So it is a poorly graded strand. So if you have a poorly graded sand and you have high water table, that's when you start getting liquefaction. So which are the zones in Delhi which are potential hazards as far as the liquefaction is concerned? All along the river Yamuna, because that's where you have the high water table, and you also have sand, and you have poorly graded sand at that. But apart from that, if you really look at our entire whatever is lying on the east side of Yamuna, that means all Noida and those type of areas, they are all in that hazardous kind of a situation, and it's only a matter of degree. Like if you are very close to Yamuna, you may have the first 6 meters which has a potential of liquefaction. If you go far away from the river course, it may be only 2 meters which is liquefiable, but it is still liquefiable. So that is the only difference that one should make. But really speaking, the entire east part of Delhi is in this type of a situation. And of course, when you come towards on the western side of Yamuna, there is definitely less of a chance. But I mean, we made studies, for example, even in the on Ring Road, which is near Yamuna, at close to ITO, for example, in that area, all that area has the potential of liquefaction. So, but it doesn't go too far. And the other thing is that if you are on rocky ground, like you go to Vasant Vihar, there is no sand there. It is all rock and more rock, and so when you are on that type of substrata, you are founding a building. It is much safer from earthquake. You see, if you ask me, the situation is pretty grim as far as the shortage of competent structural engineers are concerned. The numbers that are required are huge. When we are talking about 80% buildings cannot be called safe, how to make them safe? I mean, the only way to do it is to retrofit them. And now the technology of retrofitting has advanced considerably from what we knew it, in the old days. You've got new materials also, like fiber reinforced polymers, for example, which are less intrusive. You don't have to drill too many holes. You don't have to jacket something and make it stronger. No, it's not necessary. These are new materials which have been introduced. But the requirement of structural engineers who can, who are competent and who can do all this is there is a shortage, and that is a historical problem. We have neglected this whole core engineering, what we call, the core engineering subjects in all the institutions for a good 10 years. When this IT boom came, everybody wanted to, just go into IT, and the new institutions which were being established did not have anything called civil engineering. So there are no takers. Even if you have, you have the infrastructure for it, you have the teaching staff for it, but if there are no students, there is no use. So the new institutions that came up over almost a 10-year period, they didn't have civil engineering. Now people are realizing that they must have this because there is a shortage of it. and there is a demand from the society for it. That's one of the issues, one of the problems which is self-created. So there is a tremendous shortage when you take account of competent structural engineers, both for new buildings and more importantly for retrofitting all the buildings which exist at the moment. All of them require to be assessed whether they are safe, unsafe. If they are unsafe or not as safe as you would like them to be, then how to retrofit them. This is a very specialized job, it's not so easy. Something like 85% of the dwellings, I would say, in Delhi are made from masonry or other non-concrete buildings, I would say, in broad category, 85%. Now, there is a code which the Bureau of Indian Standard has, which is meant for masonry buildings only. So you can make assessments quite easily. Even a common man can do it. You don't require a structural expert to tell you whether what you've done is drastically wrong or right. Maybe for the finer points you require somebody. But for example, you see in this room, there is a door. Where is the next window? What is the distance between them? Does it have a lintel which is going, a lintel band which is going all around the building or not? These things even the engineer will have to find out. And that code which I am talking about has sort of prescriptive kind of solutions, like it says, okay, you must have this much distance between two openings, for example. So easily everybody has a tape. Even if the engineer comes, he will have to measure this. So you have to first find out whether there is something drastically wrong, and if there is, then you know that okay, there is something, at least above ground you have some serious problems, or you don't have some serious problems. The other thing is that if you are living in East Delhi, the first thing is to find out whether there was a geotechnical investigation done at the time when the building was made. Before we make any buildings, we have to do geotechnical investigations, from which you decide what type of foundations are required, what is the bearing capacity of that substrata. If you have to have piles, which go deep into the ground, which is the right type of foundation to do, especially when you are in a liquefiable strata, and like I said, 2 to 6 meters of it may be liquefiable, then the foundations must be lower than that. So, so above ground is, if you are a masonry building, the situation is pretty clear what you have to do, and best is to do this assessment yourself after looking at the code of practice, which you can buy from Bureau of Indian Standards. Every building has a shape, and these shapes are given in the codes again as to what is a good shape for a earthquake resistant structure and what is not. So you should have a look at your overall structural plan as you see it, from the top. What shape is it? Is it something regular? Is it irregular? Is it an L-shaped building? Is it a T-shaped building? Or is it just a rectangular building or a square building? A square building, for example, would be the best, and all the other things that I have talked about will become worse and worse and worse and worse. Because you could just imagine, if you have an L-shaped building like that and you have a ground shaking, these things are going to go apart like that. So naturally they are going to damage the building. So many of the things are common sense, but these are given in the code of practice. These at least, the people can see them for themselves. They don't have to get an expert for it. Now, building on stilts, they should never be made, firstly. But then the architects have a problem that they cannot accommodate all these cars, and they are now the number of cars are becoming more or less the same as the number of people these days, and that's we'll never be able to accommodate that. So it seems that for at least multi-storied buildings, to make them on stilts has become a necessity. But you still have to make sure that the building is safe, and that unfortunately is not a very simple issue. Why it is unsafe is that you've got all this very stiff structure above. You've got these masonry walls, which are the infill walls, which are there, which is making the building very stiff for any kind of a movement, which is bound to happen when you have an earthquake, and because of like I explained, the mass inertia, that building is going to deflect. Now suddenly you've got a different stiffness of the building and on one story below. The same thing can happen if you have a sudden change in stiffness somewhere in between. If you have a 20-story building and one floor is missing, and you don't create or recreate that stiffness by some other structural element, that is when you get into trouble. Now if you just provide stilts and you don't worry about how you are recreating what is missing as far as stiffness is concerned, you are in trouble. And this is unfortunately next code that we make. I'm sure we are going to have a more elaborate sort of provision for it, but at the moment it is just one little clause which is mentioned there, how to take care of this problem. If you are in this type of a situation where you are living in a stilted buildings, definitely it requires the intervention of a structural specialist, and a very competent structural specialist, to find out. And even he may require drawings before he can, you can't say whether this is okay or not just making a visit. Drawings are absolutely essential to give it to him, so he makes a study of it, and then he can advise what you need to do.